What's up, guys? Welcome back to this channel. It's Sukomi here once again. If you're new to this channel and you like more videos like this, I'd like you to hit on that subscribe button so you get notified when I drop a new video. In today's video, I'm going to be teaching us how to work more effectively with Power Design Workbench and how to create sketches and how to constrain sketches. So here we have here on the screen, we have a universal adapter, and in order to do that, I'm going to be explaining how to model this universal adapter by creating sketches and constraining those sketches. So the first thing I'm going to do is to create a new worksheet by pressing here and just pressing new. So let me just close this. So now we're on a new worksheet. So I'm going to navigate to the Part Design Workbench because we're working on the Part Design Workbench. So create a body, create a sketch. So I must select the plane I'm working on. So in this tutorial, I'm working on the front view. So I'm going to click on the XZ plane and select OK. So here we are on the sketcher. We are already on the sketcher. And in order to model our power adapter, I'm going to start by creating a rectangle. So I'm just going to select the rectangle icon here. So and draw a rectangle on the screen. So there we have it. And what constraining of a sketch entails is just we giving our model a fixed coordinate in space, because every model that you have, every object that you have in space must have a fixed coordinates to give it a fixed definition in space, so it's not just hovering about axis. So that's what it means to constrain a sketch, to give it a detailed dimension and to give it a detailed distance from the axis. So that's what constraining a sketch is. So with that understanding, I'm going to give this place a length of 40 millimeters and press OK. I'm going to give this an height of 50 millimeters and click on OK. So now this dimension is already detailed, but then it is still free to move about the axis. So to constrain that, I must give it a certain distance from the origin or from the axis. So I'm going to set the distance between this point and this point to be 20 millimeters, and the distance between this point and this to be 30 millimeters, and click on OK. So if you notice something, the sketch changed from white to green. So what that means is that this sketch is already fully constrained. And if we check this panel here, which is called the server messages, it says that fully constrained sketch solved in 0 seconds. So this sketch is fully constrained. That's why the color changed to green. So you just go ahead and close this already. So click on model and just change the view by clicking on this isometric view panel and bring it down. So now you can see that the rectangle on the screen, but then this rectangle is just a 2D image. I want to convert it to a 3D image. So to do that, you just select the sketch that we just did and then click on this icon, which is called the pad. Then so it's just to give it a thickness to convert 2D to 3D image. So I'm going to give it a thickness of 20 millimeters so we can see the increase, and then let's click on OK. So we have this already. So and if you notice the power adapter, the universal power adapter at the beginning of this video had the kind of round shape. So just select these edges. So to do that, just hold Ctrl down and select the 4 edges of this model, and then when you've selected the edges, just click on this. This means fillet. So fillet is to give it a kind of round edge, so smoothing the edges. So I'm going to give it a radius of 9.9 and then just click on OK. So we can see that it has changed the way the object is viewed. So now the next thing I want to do is to make some details at the top of this model. So I'm just going to click on this face, just select this face and then click on this icon is to map a sketch to the face and then create a new sketch. So I'm going to click on this line too and create 2 lines. The first one, then the second one. I'm going to click on this icon also to create an arc. So on the other side also. Okay, so there you have it, and I'm going to give it a dimension. So I'm going to give this part a dimension of 20. Okay, before that, I'm going to set an equality constraint so that as I'm changing this, I don't need to change the 2 lengths. So I'm going to set this line and this line to be equal. So just click on that line and then click on this equality constraint. I'm going to do the same for this arcs also and click on this equality constraint. So whatever dimension you alter in one will be altered in the other. So now I'm going to go ahead and give this a length of 20 millimeters, and I'm going to give you a radius of 8.9 millimeters. So click on OK. So now this sketch is constrained, but there are still some few things I need to do. So I need to give a tangency between the line and the arc. So just select the line and the arc and then click on this tangency constraint. So do it for all the edges. Here also a tangency constraint. Here also a tangency constraint. Here also a tangency constraint. So then this sketch is detailed already, but then it's still hovering about in space. So I must give it a defined dimension. So I want the distance between this point and this point to be 1 millimeter. So 1. But then and also the distance between this point and this point to be 10, so that it forms a kind of symmetry about the y-axis. So this 10 millimeters, and then you can see that the color has changed from white to green. So this sketch is fully constrained. Then just go ahead and close it. So I'm going to perform an operation which is called the pocketing operation. It's to kind of make a depression inside this. So just click on this icon which is called the pocketing, and I'm going to give it a depth of 2.0.2 millimeter and click on OK. So you can see the depth that has been created. So then I'm going to do the same for the other side of this model. I'll just click on this face and I'm going to click on the same thing, and I'm just going to replicate what I did the other time. So select the line, 2 lines, then an arc, 2 arcs, so I'm going to give it an equality constraint for the arcs also. So yes, 20, that's the dimension, 20 millimeters. Here is 9.9 radius. So I'm going to give it a tangency constraint to do this one for here also. Here also a tangency constraint. And then the distance between this point and this point, set it to be 1 millimeter. And then the distance between this and this, the horizontal distance now, to be 10. So this sketch is fully constrained. Okay, there seems to be an error, so I'm going to delete a constraint here. I'm going to delete all the dimension. So then I'm going to set an equality constraint for this arcs. And so I'm going to give it a radius of 9.9 millimeters. Oh, I think the radius should be 8.9 to create that 1 millimeter thickness. So 8.9 millimeters. So there you have it. So the distance between here and here should be 1. Also the vertical distance to create that 1 millimeter thickness. So and then to make it symmetrical about that axis, this piece should be 10. And the length of this place should be 20 millimeters. So now this sketch is fully constrained, and then just close it. And the same thing, pocket, which has a depth of 0.2, and then click on OK. So there we have it on both sides, that depression. So the next thing I'm going to do is to click on this face. I'm going to click on this face, and then I'm going to click on this face rather, and then I'm going to create another sketch on that face. So now I'm trying to create the pot. So I'm going to select this time. I'm going to select the line 2. I'm going to select the poly line 2, which helps to create multiple lines without having to select a line each time we need a line. So I'm going to click on this poly line 2, and then I'm going to create a kind of sketch for the pot. So then the way the polyline works, you can change the way the polyline works to change on different tools by just selecting M. So now we have a line. You will click on M on the keyboard, it changes to a kind of perpendicular line. If I click on M, it creates a kind of reversed perpendicular line. If I click on M again, it creates an arc. So this is what I need, an arc. So I'm just going to click on this. So then I need a line again. So I'm going to click on M again until I get to line. Okay, here I am. And then I complete this sketch. So at the any point of this, make sure that you see that yellow, the red node should change to a yellow color, meaning that there's a coincident at that point. Then you select it, and that is it. So I'm going to make this place horizontal and vertical. So I'm going to give it a vertical constraint by clicking here. And then I'm also going to give this a vertical constraint. I can do that multiple times by just selecting all what I need to be vertical and then tap the vertical constraint. Okay, I paste this one already as the vertical constraint. So I'm going to make this horizontally constrained, and I'm going to make this also horizontally constrained. So I'm going to give this a radius of 2.5 millimeters. I'm going to make here and here equal to each other by setting the equality constraint. I'm also going to make this point and this point equal to each other, and this point and this point equal to each other. So I think I'm going to set this piece to be vertically constrained. So an equality constraint between these 2 points also. And then I can give them dimension. So I don't need to give everything dimension. As long as I change the dimension of one half and it changes for the other half. So this I'm going to set an horizontal distance of 2.5 millimeters. So if the dimension is getting to the way, you can just carry dimension and shift it aside. Or you can also tap this button to remove every dimension so you can properly visualize your sketch. So then I need the dimension. I'm going to click on it back. So I'm going to set the thickness of this place to be 1 millimeter, and then this I'm going to give it a vertical height of 3 millimeters, and there you have this sketch fully dimensioned, but then it is still hovering around in space. So I'm going to constrain that. So I'm going to set distance between this point and the center point. Note the color change to yellow. It means that there was a coincident at that point. So that's the center point. So I'm going to set a vertical height of 10 between that point, or rather between the center point of this arc and then this point. I'm going to set a vertical height of 10 millimeters, and the distance between this point and this point, center point, I'm going to make it 4 millimeters, and I click on OK. So now this spot there must be 2. So I'm going to create a optical image of this on the other side. So we already know how we did the other one. So I'm going to perform the same thing once again. So this is polyline 2. So I'm going to change the behavior until it turns to an arc, then back to a line until it changes to yellow. So there's a coincident at that point. So I'm going to give you a vertical constraint here, a vertical constraint here, a vertical constraint. To zoom in, you can just use the mouse scroll wheel to zoom in and to zoom out, and that is it. So I'm going to set an equality constraint between this point and this point, between this and this, also between this and this, another equality constraint. So now let me give this a radius of 2.5 as I did at the other end. So I'm going to give this a horizontal length of 2.5 also millimeters. So I'm going to give here if I'm going to set this part to be 3. So the height of this should be 3 millimeters, and the distance of this should be 1 millimeters. So there you have it. So I'm going to bring this out so we can properly see it. So there you have it. So I'm going to set the distance between the center point of this and here. I'm going to set it to be 10, and click on enter. And also for the distance between this point and this, I'm going to set it to be 4 millimeters. So there you have it. But then this sketch is not fully constrained. So in order to constrain this sketch, okay, now the dimensions are starting to get in the way. So to have to remove the dimensions, you can just click on this icon here to remove all the dimensions to properly visualize whatever you want to do. So I'm going to set this and this to be totally constrained about the same point. So now You can see that this sketch changed the color from white to green, so it is constrained as usual. So I'm going to close it. So I'm going to perform a pocketing operation. So in order to pocket any operation, there are ways you can do it. You can either give it a kind of, so we can see the depth of this pocket. So you can either give it a depth of 10. So we can see how it is, the width is increasing, or I can give it 20. So it's going to go deeper. I can also select through all. So it's going to make it through also on two sides. So that's what I need for this situation. So I'm going to select there are also other options I can select from to face, up to face, and two dimensions, but I need only through all. So just select OK. So then we have the two ports. So I also want to add some things to this face. So I'm going to select this face and then create another sketch on this face. So I'm going to select the line tool. A polyline tool can also do what I'm about to do also. So select this and this. So a line tool and then an arc again. So I'm going to set here to be coincidental. Here and here also to be coincidental. This and this also to be coincidental. I'm also going to select here to be coincidental. And I'm going to give this a vertical constraint. So here we have it, but then it's not dimensioned yet. So I'm going to give this a dimension of 10, but first I must give this an equality constraint to make sure that it is even on both sides, and here also an equality constraint. So this should have a horizontal length of 10, and this should have a radius of 3 millimeters. So I'm going to set the height between distance between here and here, the middle point and that point to be I think 10 would do, 10 millimeters, and then distance between this point and this point, to make it symmetrical I'm going to make it 5. So it's constrained, then close it. So I'm going to pad now. I'm going to create a thickness from there. So I'm going to make it 0.1. You might not really see it, but there is something there by zooming it in using the mouse scroll wheel. So we can see the thickness there. Very small, but something is there. So I also want to perform another sketch on this face. So I'm going to click on this face, and then I'm going to click on the sketch also. Once again. So I want to perform a more complex sketch this time around. So I'm going to use the polyline tool once again. I'm going to create a sketch. So if you notice, when I'm starting the sketch, I want to I make sure that the cursor is on the axis. So the color change to green. So the line I'm going to make now is going to be coincidental to the axis point. So like this, starting from that axis, then just follow the sketch. So since it's a polyline, so I can press M to change the behavior. So I need an arc right now. Okay, now something like this. And this, and another arc. Okay, let me stop here for now and give this a distance or horizontal length of 1 millimeter. This height of 1.5. I'm going to give this arc also a radius of 1.5. So I'm going to make this vertically constrained and move this here. So I'm going to make the height of this to be 0.5. And so I'm going to set the distance between this particular point and the center point. I'm going to make it 0.5. Yes, just like this. And then I'm going to create it on the other side also. So this is just an half. I'm going to create it on the other side again. So I'm going to click on the polyline tool again. Start from the coincident of this point and create an optical image of that sketch. So M to change it to an arc. So I need a line now. And then another arc. So something like this, and this has, okay, first, this has a horizontal length of 1. This is 1.5. This is has a radius of 1.5 also. So I'm going to make this vertically constrained and then give it an height of 0.5. Okay, so here you have it, and the distance between this point and the center point, it is 0.5 also. So now the dimensions are surely getting in the way. So to see what I just finished sketching, I'm going to click on this icon. So here's what we have. So then this sketch is not yet done. I'm going to give this a radius of 1.5. And also this is a radius of 1.5. Note, I could just make these two arcs equal and just select one in order to save me the stress of having to give each one a dimension. So but this sketch is not yet complete. I'm going to click on the line tool and just draw a kind of diagonal line, not horizontal, not vertical, just diagonal, something like this. And then select on this arc tool to complete this with an arc, something like this. Yes, that's more like it. So I'm going to make a coincidence between this point and this point, and also between this point and this point. Yeah, so I'm going to give this point an angular distance between this point and the center line. So between this point, this line, and the center line, I'm going to give it an angle of 160. We'll do the same for the other side. An angle of 160. So I'm going to make this line and this line coincident also. I'm also going to make this coincident. So this sketch is complete now, but it is not yet fixed about the axis. So I'm going to set the distance between the top of this point and the middle, the center between the axis. I'm going to set the distance to be 25 millimeters. Yeah, something like this. And then the distance between the middle of this axis and the center point to be, I'm going to set the height to be 16. So this is our sketch now. So the sketch is completed, but then this is not the only thing I'm adding to this face. So I'm going to create another sketch also. So I'm going to select the polyline tool again. So I'm going to create another sketch. Using the polyline tool. So then I'm going to close this sketch. So then a lot of things need to be horizontally constrained. So this line needs to be constrained horizontally. This needs to be constrained horizontally. This also, this and this. So let's click on the horizontal constraint once. So this, and this. So horizontal constraint. This needs to be vertically constrained. This and this. So apply vertical constraint there. So now what is left is for me to give it dimensions. So I want to make here and here and here equal. So apply the equality constraint there. I'm going to give this a horizontal length of 2.5 millimeters. So I'm going to make here and here also equal, this line and this line. So equality constraint, and I'm going to give it a length of 2 millimeters. So I'm going to give this an height of 3. I'm going to give this length of 4.5. Okay, this needs to be vertically constrained. I'm going to give this a distance of 2.5 millimeters. So I'm going to give this this particular part. Okay, first I must set this height to be 1 millimeter, and then I'm going to give this a distance of 1 millimeter. So there we have the sketch. But then I need two of this particular port, so I'm going to replicate this sketch on the opposite side. So I'm going to grab my polyline tool and perform the same sketch, but now it's an optical image, like a mirror image of the particular sketch. So it's going to be something like this. Don't mind the scale of the dimension of the sketch, it's still going to be dimensioned. So I'm going to close this sketch. So I'm going to make this vertically constrained, make this also vertically constrained, make this vertically constrained. Okay, I think, okay, I'm going to make this horizontally constrained. I'm going to make this horizontally constrained. So let me give it dimensions. This point, and this line, and equality constraint for it. This should be vertically constrained. This point and this point, I'm going to make it also an equality constraint between them. I'm going to give it a length of 2 millimeters. Here has a length of 2.5. Here has a length of 4.5. Here has a length of 2.5 also. Okay, so okay, this sketch is not just, so I'm going to grab my polyline tool again. This sketch is not just a single line, it is more of something like this and then like this. So I'm going to make this vertically constrained, this vertically constrained. So I'll give this a length of 2.5. I'm going to give this a diagonal length of 1 millimeter. Here also a height of 1 millimeter. So I'm going to give you a height of 3 millimeters. Okay, I'm going to press Ctrl Z to revert that. So I'm going to bring this down and give this, since there's an equality constraint between this point, this line and this line, so whatever change I make is going to be affected. I'm going to give this a height of 0.5. Yeah, so I'm going to make this 3 millimeter. So yes, here we have our sketch. Then it is already similar to the other sketch already. But then these sketches are, though they are dimensioned, but they are not fixed. They are still moving freely about this axis. So it appears that this length here is not dimension. So I'm going to give it a dimension of 0.5 since it's that it's meant to be. So these sketches are, though they are dimensioned, they are not constrained. So the distance between this point and this center point, I'm going to make it 3.5. And also the same thing for here. I'm going to make it 3.5. Okay, yes, and then the vertical distance between this point and this point, I'm going to make it 8. Okay, instead of that, I'm going to make distance between this far point and this middle point. I'm going to make it 11 millimeters. I'm going to do the same for the other, and by the time I'm done with this, the sketch should be constrained. So yeah, we have a fully constrained sketch. So then I'm just going to close this. So here's the sketch that we just made, and I'm going to perform a pocketing operation here. So since it's a port, it has to go in a depression. So just click on this, and I'm going to give it a distance or depth of 7 millimeters. So just click on OK. So we can see that it has been effected already. So the next thing I want to do is to work on this back. So I'm going to select this face and click on another sketch. So I'm going to create another sketch on this face. This time around, I'm going to create in the ports, the connectors where you connect it into the socket. So I'm going to grab the rectangle tool and just create a simple rectangle here. Actually, I need 3 rectangles, so another will be here. Okay, first this sketch is upside down, so I'm going to I'm going to delete this sketch. Since it's upside down, the connector should be aligned with the port. So it should be on this face upper here. So nice. That's more like it. So these are the ports, and so the connector should be right up here. So I'm going to grab the rectangle to create rectangles, three rectangles. So here should have a length of 3. Here should have an height of 5. Note these dimensions I'm using in this sketch are arbitrary dimensions. They are not fixed. So depending on what you are trying to get as the outcome, so you can just tweak the dimensions to what you want it to be. So I'm going to make here and here equal. I think I'm going to delete this sketch and make that first. So there's 5 and there's 3. So this rectangle is already fixed, but then it's not constrained about the axis. So the distance between this top point and this base point, I'm going to set it to be 25 so that it is aligned with the sketch in front. Remember the distance between the connector, the top of the connector, the top of the port, and then the middle line was 25. So to align it, I'm going to do the same here. And to make it symmetrical about this point, I'm just going to make it symmetrical by making the distance between this point and this point to be 1.5. Yeah, something like this. I'm going to close this sketch and then pad it, make it a 3D image. I'm going to give it an height of 15 and then okay. But then I still need more connectors behind there, so I'm going to create another sketch here. So I'm going to grab my rectangle tool again and create 2 rectangles. I'm going to make here and here equal, and here and here I'm going to make it also equal. So the length of this place should be 5, and the length of this should be, the height rather of that should be 3. So click on OK. So I'm going to give these distances to the axis. So from here, this point to this point, I'm going to make it 8. I'm going to do the same for here, this point and this point. I'm going to make it 8 millimeters, and the height between this point and this point, I'm going to make it 3.5. So the same for the other, and it should be constrained. So our sketch is constrained. So I'm going to go ahead and close this and also pad. But this time around, I'm not padding to 15. I'm going to pad to 10, and I'm going to click on OK. So I'm going to select this face, not this face this time around, this face, and then I'm going to, well, on second thought, if you notice this, after padding this particular sketch, there's a kind of space between the main universal adapter and this connector. So in order to fix that kind of groove that is between there, just double click on this pad. And remember I said that there are different ways you could pocket. There are also different ways you can pad a particular sketch. So you can do dimensional pad, you can pad to first, pad to last. So I'm going to do 2 dimensions padding. So that means I'm padding in both ways. So if you take a look at this sketch, then it is going upwards and downwards. So 2 ways. So I'm going to make the downward padding to be not 100. 100 is a lot. So I'm going to make it 3, and that should fix it. So we can say that it's going into it now. So there you have it fixed. And I'm going to select this face and click on sketch. So I'm going to create a kind of smaller rectangle here for the connectors, because we have a connector here, then we have 2 main connectors that actually drive the current to the power adapter. So I'm going to select this rectangle too and create a kind of a smaller rectangle inside this former rectangle we created. And I'm going to make here this point equal to this point using the equality constraint. I'm going to make this point equal to this point also using the equality constraint, and I'm going to give this a distance of so this time around this space is not be 5. I'm going to make it 4.75 because I want it to be inside the bigger rectangle. So I'm going to make this, I'm going to give it an height of 2.75. So basically the thickness is going to be 5 minus 4.75. So the thickness around should be around 0.125 since it's going around it. So there you have it. So these sketches are actually done, but let me set the distance. So distance between this point and this point, the horizontal distance, I'm going to set it to be 8.125 to compensate for the thickness that we've removed. So for the other side, 8.12 8.125, and then okay, and then the vertical height between that point and the center point, I'm going to make it to be 3.625. So basically what I did is that I added 0.125 to the dimensions of the former rectangle. So 625 and enter. So I'm going to do the same for here. The vertical height, that is 3.625. And okay, so this smaller rectangle are now positioned inside it with a thickness of 0.125. So there you have it. So just close the sketch, and then I'm going to pad this sketch also. So now I'm going to pad it to 5, so it's at the same height with this. Remember, this has the height of 15, this has the height of 10, so 10 plus 5 is equal to 15 also. So then okay, so then we are actually almost done with this sketch, just to perform some finishing operation. So I'm going to select these edges. It's something called chamfering operation. So chamfering operation is to kind of remove an edge and make it a plane. So select the whole edge of this connector and then these two edges, and then click on this chamfer. This is fillet, this is chamfer, then chamfer is to create this kind of shape. Then click on OK, and there you have it. This is a complete sketch already, and we are done with this modeling in this universal power adapter. So there is it. But then to just do some finishing and to change the appearance of this, I'm going to select this chamfer, then go to view, and then go to um appearances here and click on default. I'm going to change the material to shiny plastic to be more realistic. The material is actually made up of plastic, and I'm going to close the sketch and still select this chamfer, then right click on this chamfer and then click on select colors. So now I'm going to be giving this a kind of color to make it look like the original thing. So I'm going to select this. Remember I said to zoom in, use the mouse control wheel, use the mouse wheel to zoom in, and then this and this, and let's select these parts. So I'm basically trying to add a color to all these selected parts, not all. So this may be hard at first, navigating and rotating this. To rotate this particular image, what you do is you hold control down, then you hold the right mouse click down, and you hold the middle mouse button down, and then rotate. That's how you do it. At first it might not seem easy, but then with practice and with time you get good at it. So I'm going to select this part. So one important thing to note here is that when selecting these parts, you must press Ctrl, because it's going to be painful forgetting to press Ctrl after selecting a number of parts, and then you have to start selecting from the beginning again. So don't forget to hold the Ctrl button down when you are selecting these parts, because imagine after selecting like 15 parts, then you forget to press Ctrl, then you have to start selecting all over again. So that's a trouble. And let's click on here and select this part. So I think that's all I need for this particular. Okay, I think that's I've selected what I need. So you just click on this small box here. So I'm going to select the color. I want it to be orange. So I'll just change some few things here. I'll make here 60 and click on OK. So it has this kind of reddish orange feel to it. So here should be normally there should be a LED indicator here to indicate when there's current flowing through this power adapter. So I'm going to make this red. So just to show that there's kind of LED there behind it. So I'm going to select here. Okay, I think that's all. Okay, that's so. So I'm going to select here. I'm just click on red. It should be red. So I want a kind of warmer kind of red or darker kind of red. So I just select OK. There you have it. So just select isometric view to view it properly. So the last thing I want to do now is just to these connectors. Most times these connectors are always silverish or gold, but I'm going to be using gold. I know this is just an appearance. It doesn't just an appearance. It could be any color, but I just want it to be kind of standard. So this face. Remember, hold the control button down while selecting these faces. So I think I've selected the pots. So and then I click on color and I'm going to select gold and just make it darker a little bit deeper and okay. So there you have it. And when you are done, just click on OK and isometric and use this fit icon to just bring it up to scale. And so here you have it. This is the full working model of a universal power adapter. So that's it, guys. This is how to perform operations in the part design workbench using sketches, constraining sketches, and modeling something out of it. So with this idea, you can model almost anything you want to model by just implementing this method. So that's been it, guys. If this video was helpful to you and impactful to you, I'd like you to give it a like and also don't forget to subscribe so you get notified when I drop new videos. So guys, till next time, keep practicing.